So moving on with task number 4, we are at the decoder. And in addition to its encoding decoding functionality, decoder also gives us, so we are at the decoder. In the previous video we've looked into encoding decoding, and now we're going to look into hashing. Decoder also gives us the option to generate hash sums for our entered data. Alright. Hashing is a one-way process that is used to transform data into a unique signature. To be a hashing algorithm, the resulting output must be impossible to be reversed. Now, a good hashing algorithm will ensure that every piece of data entered will have a completely unique hash. For example, using the MD5 algorithm, which has been used a lot historically to generate a hash sum for the text, MD sum returns this. So I believe in Windows and Linux it's easier. MD5 sum, or what was it? MD5 check. There was so Windows MD5 sum terminal. I believe it was certutil. So you would be using certutil minus hash file MD5. That's for the file, but for, let's say, for a string, how to get the MD5 hash of a string directly in the terminal. In the Windows terminal, in Windows, let's see, certutil minus hash file. Either way, it's easier in Linux, much easier. But for that purpose, so if you have a file, you just use the file and that. But what we could do, for example, in this situation, to actually do this, we can actually copy that string, and then we can say echo the string into this file.txt. Then we use certutil minus hash file MD5 this file.txt. So was it minus hash file? Certutil, what was it? Certutil minus hash file MD5. Certutil minus hash file, then we have the file, so it's not minus, and then we have MD5, and then we have the MD5 of the file, but not of the string. So MD5 online string. So if we want to actually use this string, we can generate, and we can see the MD5 hash for AE1 and ends with E8C, for AE1 and ends with E8C. Using the same algorithm to generate a hash sum for MD5 sum gives us a completely different, as you can see, it's a completely different 13B DAD or DAD, 13B DAD. For this reason, hashes are frequently used to verify the integrity of files and documents, as you've seen in Windows, as even a very small change to the file will result in the hash sum changing significantly. The MD5 algorithm is deprecated, so this is really important to know and should not be used for modern applications. Equally, hashes are also used to securely store passwords due to one-way hashing process, meaning that the hashes can never be reversed. The password will be relatively secure even if the database is leaked. Actually not. If you're using a algorithm such as this is easily compromisable, because you you can easily write a password cracker in Python, for example, or in whatever language you want, that would actually try to do a dictionary attack against your hash. When a user creates a password, it is hashed and stored by the application. When the user tries to log in, the application will then hash the password they submit and check it against the stored hash. Of course, that's how you would actually also use the password cracking script. If the hash is matched, then the password was correct. When using this methodology, an application never has to store the original plain text password. Well, like I said, in theory it looks good on paper, but in practice it's actually very not so okay doing so. Hashing in Decoder. So we have Burp fired up. Decoder allows us to generate hash sums for data directly within Burp Suite. This works in much the same way as the encoding-decoding options we saw in the previous task. Specifically, we click on the hash drop-down menu and select the algorithm from the list. Now, so going back here, we have the hash, and we have a very large list of algorithms, slightly larger than for encoders, for encode decode. Hashing is a larger list. This is significantly longer than it, so it's exactly what I said. Continuing on the early example, let's enter the MD5 sum into the input box, then scroll down the list until we find MD5. So we go to MD5, and then this will actually send us into the hex view, of course. If we click on the text view, this is the text view, but this is the hex view. This is because the output of a hashing algorithm does not return pure ASCII Unicode text. As such, it is common to take the resultant output and turn it into a hexadecimal string. This is the form of hash. So you turn this as hexadecimal, ASCII hex, no. You turn this, you decode this as hex, actually. So decode as hex or ASCII hex. So let's finish this by applying an ASCII hex encoding. We need to encode as ASCII hex, and there we go. That's when you have 41E, 4AE, E8C. To create the need hex string from our initial example. So what you do actually, so you enter the MD5. Like I said, you enter the MD5 in here. Click on the MD5. Then you encode the hex as ASCII hex to get the hash. Let's put this into practice with a few examples. Using Decoder, what is the SHA-256 hash sum of the phrase let's get hashing? So let's get hashing is gonna be there, and then we encode this as, so first we hash this as SHA-256, and then we encode this as ASCII hex. Then we copy that, we paste it in here. Generate an MD4 hash sum of the phrase insecure algorithms. MD4, I would say it's also even more insecure than MD5. So you encode, what do they want us to do? You encode this as base 64 before submitting. What do they want us to do? Encoded this as base 64 before submitting. So you have MD4, then you encode as base 64, so they want the base 64. Yep. Let's look at an in-context example. First, download the file attached to this task. So I've already downloaded it. It's a zip file, and this is where we actually have the keys. So this zip file holds for SSH keys. Now Read the problem specification below. Some joker has messed with my SSH keys. There are 4 keys in the directory and I have no idea which is the real one. The MD5 hash sum for my key is this one. Could you find it for me? Submit the correct key as your answer. So let's actually open this with Notepad. Copy the key 1 and then go to Burp Suite, MD5 hash sum. So they want MD5 hash sum. Just paste it over there. Then you would hash as MD5. Then you would encode as ASCII hex, and then you would check against B52. We would check this against what they have, 316. Okay, then so obviously the first key is not the correct one. We go ahead and do the second key. Let's actually see if I can paste it directly. Copy, paste it over there, encode as ASCII hex, 915 versus 316. So we're actually moving on to key number 3. Copy the key, going back here, paste it, encode as ASCII hex, 316 9F8. 316 9F8. Submit the correct key name. So this was key number 3. Alright, so this was all about hashing. Let's actually overview the comparer. Let's see how we're with the recording here. 12 minutes. So let's look into the comparer, and then in the next video we're actually going to look into the example and maybe the sequencer. So as the name suggests, comparer allows us to compare 2 pieces of data. Now for that specific matter, I would actually want to say that I do use comparer very often in my penetration tests. So the comparer is over here, and I actually send stuff. So I actually send requests to the comparer. So for example, let's say that I usually do this, so not necessarily usually, but I often do this when I'm testing for authorization and I'm checking the responses to actually see if they match precisely. And if they do not match, if they have small differences, so instead of having me to go through them manually, I would actually just compare 2 responses that are slightly different to actually determine whether or not there is an authorization issue or not. So this is when this is what I do a lot in testing. This is when I'm using the comparer. So it allows us to compare 2 pieces of data either by ASCII words or by bytes. So we look at the interface, we can see that we have 2 small windows here. The first one, select item 1 and select item 2. Both of them will be populated with the items that you're actually sending to the comparer. So the interface can be they split it into 3 main parts. The first part, we have items being compared. So this is the one. When we load data into comparer, it will appear as rows in these tables. So for example, you can just load. On the upper right, we have the options for pasting data from the clipboard. You can just paste from the clipboard. Let's just copy this string, go here into the comparer and actually paste the first one, and actually just paste a shorter version of it, the second one. So you can see that you have the comparer here. In the first one you have the first one highlighted. In the second window you have the second one highlighted. You can compare by words and by bytes. If you compare by words, it's gonna give you the deleted, in this situation, the second one doesn't contain this, so the deleted are highlighted in blue and the added are highlighted in yellow and the modified in red. So that's actually how the compare works. And at a glance, we have options for pasting data, loading data from a file, removing the current row, and clearing all the data. So that's what you have there. We can also load data into compare from other modules. So send to compare, for example, I can just send to compare from the repeater or from the proxy. I could just send to compare request response. So this actually gives me the option to send the request or the response, but if I click in the request, I can just send it to compare. If I click on the response, I can send it to the compare. Alright, when we have loaded data into compare, we get a pop-up window showing us the comparison as I've showed you previously. Once again, there are three distinct parts and I've explained them to you. You can also sync the view, for example. So let's actually do another compare here. Let's just compare. We can compare bytes and we can sync view, but sync view actually is very useful when you have lengthier text, because when you scroll, so let's say for example I just copy a larger piece of text. Let's take a larger piece of text from somewhere over here, like this one. Take this one and actually paste it into the comparer. So we clear, actually we paste the first one, and then let's actually paste a second one, and then compare words. If I have the sync view, it's actually going to scroll both of them simultaneously. If the sync view is not used, it's not going to scroll them simultaneously, as you can see. So sync view is really useful because you can see exactly where the differences, modifications, deletions, additions are. Alright, now going back to our compare overview. Familiarize yourself with the compare interface. I believe we've done that. Alright, now I believe this is enough for this video, so we're actually going to look into the example because in the next video, because we need to fire up the machine which is already fired up, and actually send something to the comparer. Or let's actually see, maybe we can do this in about 2 or 3 minutes. There are many situations where being able to quickly compare two potentially very large pieces of data can come in handy. When performing a login, brute force, or credential stuffing attack, you may wish to compare two responses with different lengths to see whether the differences lie, and whether the differences indicate a successful login. Navigate to this one. So I'm actually I'm already connected to their VPN here. So the VPN is connected to TryHackMe. So what do we need to do next? Try to log in with an invalid username and password. Let's say admin1, and then we actually look at the request here. So let's just look at the request here in the proxy. Post, it's a post request admin1. All right. That's what I did. So let's say we've completed that. Send a request to repeater with Control R. So let's actually send this to the repeater. Alright. Did that. Send the request, then right click on the response. Send the response to the comparer. Now in the repeater tab, change the credentials to support admin and this password. So support admin and this password, send it, and now send this response to the comparer. I believe that's what I want us to do. Send the request again that passed the new responses to the comparer. So I believe we did that. Compare the two responses. Can you identify the main difference? Let's actually see. So we are in the comparer. We remove the first. What do we need to remove? So let's see. We remove the first two, and then we are left with our two responses. We compare our two responses by words, and let's actually look at the differences here. Let's sync the views. We can see that in this situation there are some differences. First off, there is a difference in length. So 674 versus 593. We also have the location, which is different. So in this case, support login to support. We can see the length is different, the time is different, the cookie is different, of course. Now, in this situation, you're being redirected to support login. And then in this situation, you are actually being redirected to support. Since you are logging in as a support admin, this would actually tell us that you're actually being redirected and your login has been successful. Let's actually look at the repeater here. Follow redirection. Let's actually follow it one more time. Support login. Not really sure if this was actually correct, but let's see. So it was support admin and the password pasted. You have no tickets. Let's actually copy this and actually try to find that in here. You have no tickets. It doesn't say anything about that. Support admin. Let's send it one more time. Follow the redirection. Follow the redirection. You have no tickets. Interesting. Support login. You're assigned tickets. Support home. Get support login. I wonder why. Because we've used the correct username and the correct password. This has been posted. If we send it, you should be redirected automatically to target URL support. So if you follow the redirection, you get the support, and then you get another redirection. It's interesting. Regardless, I think I've done this correctly, but if not, and if someone in the comments has actually, or if someone watching this video thinks that I haven't done anything correctly, just criticize me in the comments section. Compare the two responses. Can you identify the main difference? That's actually what I did. Now, in the next video, we're actually going to look into the sequencer, and we will actually be finishing with this other modules, and then let's actually look into the learning path one more time. What I want to say is that exciting things are coming up. So once we finish the other modules and then we move into the extender, I would actually say that I'm not really, unless there are a lot of requests for me to keep on going with this one, I may be actually stopping this at Burp Suite, because I think Burp Suite is really important, and then start another playlist here on YouTube for actually going through hexplaining.com, because hexplaining.com is actually really interesting. So we can see the lessons here. There are a lot of lessons that we will be accessing, and there's a lot to learn about application security once we go through these interactive lessons. So unless some of you really want me to go through this network security, there's a lot of Nmap that I'm not really interested in, vulnerability research, Metasploit. I'm definitely not interested in Metasploit because I'm interested in application security. So I do not have to actually finish this path because I'm not interested in getting a certificate. I don't care about certificates. And privilege escalation. So it's not about privilege escalation unless you're a red teamer and this or network penetration tester. This series is not for that purpose. So again, let me know in the comment section if you're excited about getting into hacksplaining and actually finishing with the Burp suite. And with that, I'm finishing this video here.